For a while now I'm using one of these super cheap $5 sonoff relay boards, and I want to show to you how to modify it to work as a garage door opener, and also to control it via Telegram, and also to get notifications if the garage door is opened via Telegram. For this we are for once using one of these sonoff switches, and also one reed contact. We need some magnetic reed contact, for example like this one from an alarming system, or this one, it's a super cheap eBay. Yeah, they are 10 for, I think they were $8 or so, including the screws and the magnets you have to put on the garage door. And yeah, so I will show you how to modify the sonoff switch, and also how to install it in the garage, and what you need to do on Telegram to get it working. Okay, so I want to begin with the modifying of the Domus relay, but first I have to say a disclaimer. This switch is working with mains voltage, with 230 volt in my case, but also it is available for 110 volt, I think. It goes from 90 volt to 250. And if you are not familiar with so high voltages and so on, I cannot recommend you to do it. But there's also a sonoff relay for 5 volt available. Then I would suggest to use this one, but I don't have any one of them here, so I don't can show how to solder it or how to modify it. But it's a little bit easier, because on the 5 volt device you don't have to modify the PCB itself, which in this case is needed. Okay, so what I am going to do is, I will show. You can open them if you have long enough fingernails, pretty easy. And otherwise you can use some small screwdriver, some flat screwdriver, or anything else. And here on the PCB you can see these big traces, and normally the relay that is here would switch the main voltage through to the other side of the PCB. One side is always connected and the other side is connected via this trace, and there's a relay between, and the relay is bridging these two pads and going to here, and will bring out the main voltage to the other side. As you can also see on the case, on one side is the input mains, and on the other side is the mains output. And as we don't want to have mains on the output, that is because on the normal garage door or an electric garage door we have some push button inputs, which we want to use to connect the relay to, and we are gonna cut this fat trace here and also this trace here to take the main voltages back or away from the relay and the away from the other side of the sonoff switch. That is the biggest change we need to do on the PCB. Another one is that we will change the memory. It's an Sti Flash, and I have here other ones. Normally there is an 512 kilobyte flash installed, but I'm gonna install 4 megabyte flash storage on it to have the over-the-air update possibilities ready. Then is also the LED, which is a 2-color LED, one green and one red side is available, but on the PCB only one side is connected. That's because normally you can also get a version where here is another microcontroller and an RF module, which isn't populated on this one. That's because, or that's why it is cheaper then. But the red side of the LED is connected somewhere here on the pads of the second microcontroller, and we need to make a bridge to the chip, to the ESP chip itself. But that's a modification you don't really need to do. It's just that I'm doing it to have both colors available. That depends on your taste. Then also we need some pin header like this for once to program the flash or the ESP itself, and also for the magnetic contact, the read contact. It is also needed, or it's easier than to use it. To cut the PCB, I'm going to use one of these cutters, and I will start around here, and will go very far into the PCB, because you can see the copper traces are going quite far into the PCB itself. It's maybe a little bit hard to see. There you can see the text, and so far is also the copper on the PCB itself. And so we need to cut the complete corner away here. I use one of my older cutters, which is damaged a bit, because it is it can be that the cutter itself will break when I try to cut the PCB. So I'm gonna wiggle it a little bit back and forth to make the cutting a bit easier. But I will gently push into the PCB, and now I'm through. And I'm also gonna do the same here. First the outer PCB part, like this. And then I am going to go deeper into the PCB, nearly to the resistor, but you have to be a little bit careful to not destroy the connection of the resistor. And here I'm also going to wiggle a little bit. Nearly like that. And I also have to say again, this is 230 mains voltage, or in which area of the world you are. Don't do it if you don't trust it, or if you don't know how to do it. We now have the PCB successfully modified, and we can see that the trace is successfully cut away, and the resistor is still good in contact. What we now need to do is to bridge these two contacts to make it like a switch. The relay is connecting these two traces. So this and this will be connected here via the relay, and there we are soldering. I am using a normal soldering iron without any station. It should work with any normal, not too big soldering iron. And I will also try to bridge these two contacts without any additional copper or so, just via solder. Sometimes it works, but sometimes not. Okay, that looks kind of good. It is now bridged. It doesn't look perfect, but it is enough. And that way we have the relay clothing these two contacts. Yeah. The next part is the Sti Flash. I soldered it before the pin header because that way it's a little bit easier, but it's still kind of difficult because there's the switch and the LED nearby, and also the SPI flash I'm using is a little bit bigger than the pads of the PCB, but it still works, and I modify every sonoff device I have with these flashes. So I will link all the parts down in the description because sometimes they are hard to find. The flash itself is this, and we need to look at it because there is one dot at the top, you can see right here, and on the old one is also this dot, and it needs to be orientated the same way as the old one. I will try to show that as close as possible. What I am doing is I will first make a big blob of solder to all the 4 pins on one side. To have them as they would be only one pin, and that way we can desolder it easier. On one side it's now ready, and now I'm going to the other side, which is a little bit harder to do because of the LED in the near. But it's now away. There's some solder left on the connector. I will remove it with a screwdriver. We now want to align the new SPI flash on top of the 8 connections and to solder it onto the pads. I'm also using the same soldering iron. And I start at the bottom because there it is easier to solder than where the LED is. I'm going to wash it a little bit to make it more aligned, and then we can solder the rest. Okay, now this side is perfectly soldered. You have to look closely, then every leg is soldered onto the PCB. The SPI flash is now changed, and now I will solder 5 pieces of these pin headers into the holes, which are here. They are needed to program the ESP, and also we will connect the read contact to it. I will hold it from the back side, but I will first solder one pin that I am not touching with my finger, otherwise it would be kind of hot with the solder on spot. Like that. This way now the pins are holding itself in, and I can solder the rest without holding it anymore from the back side. And that way we have the pin header soldered in correctly. Now the last thing I am going to do is connect. The last thing I am going to do is to solder this pin from this SOT23 socket. Yeah, the upper one, which is the red side of the LED, which goes from this resistor via this trace to that area, and I am going to connect it to the outer pin here of the ESP on the, yeah, it's very hard to show, but I'm trying it. This last pin that is on this side of the ESP, I'm going to solder it there, but this is really not easy, and it's also optional, yeah, if you don't want to like or want to have the red LED blinking. For this I am using this, yeah, copper wire, 0.2 millimeters, like this. It needs to be tinned at the end. It is flying somewhere here. I am going to solder it first onto the top pin. That way it is a little bit easier. Yeah, like this. And then I'm going to cut it somewhere. And it's now connected. I will push it through the trace of the PCB like this, and then it's coming out here on the bottom, and I will make it around this side of the chip. The reason for that is because here is the antenna, and I don't want to go over the antenna with my copper wire. And there we can also cut it at the appropriate length. Cut there. And now I'm also going to tin the other end. Now comes the hard part. I will tin a little bit the copper end, or the trace of the ESP, and then I'm going to reflow it like that, and it should also don't come apart while moving it a little bit. Yeah, that looks good. It's now soldered to the last pin, and we can also bend the rest of it a little bit onto the PCB so it won't move anywhere. I will now solder one of these reed contacts to the pin header and to the PCB. In this case, just to show it to you. In reality these cables are a bit short, but it depends on your garage door how long you need them. I will just take one out and solder the pin, one on a ground connection and one onto the last pin header connection here. So this is one input of the ESP8266, and here the last connection is one ground connection. So I will solder one pin there. Like this is one connection, and then the other I will directly solder onto the pin. Like that. Yeah, but that's just for showing it to you. Normally you would also need to guide it through the case. I will try if it fits here, but it does. So you can really just solder it on and do the rest later. So if your cable length is enough, then you could use it like this. Yeah, so the next part is the programming part. For this we need some DuPont wires and also some kind of USB to serial converter. In my case I use this one. The auto programmer is just wrong. In the inside there's also one of these CH340 chips from WCH. With a small microcontroller, and I think that's a padlock which is used to turn on or off the output power, but that don't belong here in this video. We need to connect 4 DuPont wires, which I will take from here. And we are going to need one ground, one RX, one TX and one 3.3 volt pin. This totally depends on your serial converter. In my case here is an 5 volt to 3.3 volt converter inside, but on some boards the converter isn't there and it will only use the CH340 converter as a 3.3 volt converter, which does not can supply that much amp to power up the ESP, which will need around 80 milliampere, and that is too much for the CH340. In that case you have to use another 3.3 volt converter. I have connected the 4 pins here on the USB serial converter, and we now also need to connect them onto the board itself. So we have first ground, then we have the RX pin, then the TX pin, and then the 3.3 volt. We now can do the programming part on the PC, but for that I will switch to the monitor. Before I will show that, you need to hold the push button here, and then you can plug it in the USB port of the PC to program it via the Arduino Ide, and we will do this next. So to begin with the programming, you first would need to install the Arduino Ide. If you haven't got already, you can download the Windows installer or Linux or Mac OS, whatever you are on. And also we need the ESP8266 core or library, and we can install it via this link into the boards manager. I will copy it and I will start the Arduino Ide I am having here, which has already the code in it. And to input the new ESP8266 library, we have to add the link into the board manager settings, and after that we can go to the board manager itself, and after it has loaded we can search for ESP, and then we will find the ESP library that we can install. This will take some time because it is quite big, but there are many boards inside and everything you need to get the ESP8266 running. Some of you may also have it already installed, so you don't need to do it again, of course. Then we also need some libraries. For once, the Arduino JSON library I will show in a second, and also the Universal Telegram bot library, which is from Brian Locke, and I'm really thankful to him. And then the other libraries should be inside of the ESP8266 library itself. We have, for example, the Wi-Fi manager library, and also the Arduino over-the-air library to get the over-the-air updates running.
Okay, so after the installation of the ESP8266 library is done, we can close the boards manager, and then we need to install the two libraries, which we can do via Sketch and then via libraries and via the library manager. First I will search for the JSON library, and we need the Arduino JSON by Benoit Blanchon. And there it is important to select a version before version 6, so we need to scroll a bit down, and there we have 5.13.5, and I will install that. This will not take so long as the other one. And then we also need to install the Telegram library, which I will do right now. And yeah, the one from Brian Luck, and there we can install the 1.1 version. And this also doesn't take so long. Yeah, so the sketch you will get via the description. I will put it down there, and you can just open it. And yeah, after the ESP library is installed, you also have to select one board of it. I am selecting the Vmos D1 Mini. It's not the sonoff one, but it works quite good. And so you can use that. Also then you have to select the flash or the spiff, which is in this case 1 megabyte spiff, and 4 MB flash size itself, which we can do like that. And then we also need to select the COM port where the serial converter is connected. It will be shown here. In my case I know it is this one or another one. And then we can first test to compile it. I will just click on compile, and then we will see if it works. Okay, so there we also need the Wi-Fi manager extra. So back to the library manager, and then we input Wi-Fi manager, and here we have the Wi-Fi manager. And there we can also install the newest version, which doesn't take so long. Okay, let's try again. Okay, that worked as it should. And we can look a little bit through the code. For once, here is the access point name and access point password that the ESP will create, where you can then set the Wi-Fi credentials to your real Wi-Fi network and also the Telegram bot token. We have here some message handling for the Telegram library, which will react on different things depending on what message you will send. And then we have a function to send the message back to the Telegram. Okay, I will now connect the sonoff relay board while pushing the push button, and you heard it maybe that it would that it is recognized from the CH340 USB to serial converter, which we now have to select here. And then we can click on upload, and it should do everything as we want. It will take some time. Okay, that looks good. So after we have now successfully programmed the garage door opener, we can unplug the UART converter and store it away for next time. And we now want to put the case around the PCB, which I will do now. For this I will put the reed contact to the outside through the case, kind of like this, and then I will put the back cover on again. If it is in the right position, and now it should kind of like this. So we can
get to the screws of the cable connections, we will install on one side one of these power cables. You can get them from any old device and just cut it and use it for this one. But here again, the disclaimer, this is mains voltage and you really need to know what you are doing. I'm just doing it here for showing purpose. So normally you would need some kind of crimp at the end. We have here some tiny clamps that are bent to the downside of the PCB, and I will try to just bend them a little bit up so I can plug my cable in better. It is not so important which side is which side. You can just take the one you like, but you have to be careful that you take the input side and not the output side, otherwise it would end not very good, or it doesn't work at all. And I will screw the cable in, and the other side also. Kind of like this. Those are now good, and we can put the top onto it, and there are the screws in some extra bag which we can then also screw into the case. And you should also not leave cables outside. You should shorten them so the isolation isn't away here. On the other side you can then connect a 2-wire cable which will go onto the garage door itself. So this now should be ready to plug into the mains voltage, which I will do now, and you should see it blinking shortly. There we have some light. And the button is doing nothing right now. Only if you want to reset the whole settings, you can unplug it, and while you plug it in, you then have to quickly press the button and it will reset all the settings. So if you plug it in and see the first light, then you need to push the button. So like this. And after the blinking, you know, okay, everything is erased. Then I will plug it in and it will boot again. And now it should also make a new Wi-Fi network, as we can see here, which is garage door. To create a bot, you will need to send /start to @botfather, which you can see here, and then we can make a new bot by clicking on new bot, and then it will say, okay, we need to select a name for it, and we are going to call it just garage door 1 2 3 4 5 6, like that. And then we need to select a name for the bot itself, like @botfather, but this time @garagedoor_bot or something like that. There will be many usernames taken, but we have to search for one that is available. So I will just name it garagedoor 1 2 3 4 5 6 _bot, and I will see if it's available. So it's available, and now we can already see the bot token which we need. So I will copy it, and also we can write a message to the bot via this button, and there we can go on start, and now the bot can message us back. We need to connect to the Wi-Fi of the garage door, which I will do now. And after that we don't have any internet connection anymore because we are connected to the Wi-Fi itself. We then need to connect to the IP address of the sonoff switch, which is 192.168.4.1, and we will open it. And there we can configure the Wi-Fi settings of the sonoff switch itself, and also put in our data, which is it will show all the Wi-Fi networks. I will select my Wi-Fi network, the password is already in, and also we need to input our Telegram user ID, which I will show in the moment. On mine it's already set. You can send a message to @userinfobot and it will print back your user ID. And here I'm now putting in the Telegram token, and then we click on save. And in a moment it will connect to my Wi-Fi network at home, and we should see that it will lose the connection to the connection of the sonoff switch. So it now loses the connection and will reconnect to my own Wi-Fi network. And we already get a message from the garage door that it was restarted. And we now can control it or get some infos, as we see here. So it says who am I, it will say the state of the garage door, if it's open or closed, it will say its IP address, how good the Wi-Fi is, and which Wi-Fi name it is in, and how much RAM is available, what the flash ID is, and so on. We can now also open the garage door or close, it depends on which state it is right now, and you should hear it click. So you heard the clicking noise, and it will also send a message that the garage door was moved successfully. Also, if I'm now taking the read contact and put a magnet onto it, the garage door controller will send a message to Telegram that the garage door has moved, so it's now closed. And if I will put the magnet away, it should send another message that the garage door is now open, which will also be seen here. Then we can also reboot the whole system, or we could send a reset message which will delete every settings on the device, so it will forget the Wi-Fi network and also forget the Telegram user ID and the Telegram token. So here's how I have it installed in my garage. It's for once plugged in here into the main socket. Then it will go to the sonoff switch, which then for once goes via a cable here on top into the garage door controller itself. And I will show you where it goes. In this case here are two connections where it is screwed into, where also another push button is installed inside my house to use it. Then the other side, or the read contact, is going here, and there is the cable going, and it's here on top where is the sensor inserted in some 3D printed part. Also on the other side of the garage door is a magnet, which is also in a 3D printed case. If I now send the close message or the move message via my phone, the garage door should move shortly after, as we can see here, and it will also show it in the Telegram. And also I have here the D6 smartwatch, and it should also vibrate when the garage door is closed. So it's now closed, it will send the message, and you can now see it here that it is successfully closed. I can now send it again to open the garage door like this. The read contact you have to mount yourself, and you have to find a good way where it will stay at the magnet in closed position. The whole system is working for me now for about 1.5 years, and one problem I had was the restart or hanging of the ESP a while, but I solved this issue by bringing a Wi-Fi network closer to the sonoff switch or to the garage. That way I solved the reconnection errors that are happening. And yeah, so if you have any questions, ask down in the comments. If you like to see more, watch my other videos, and yeah, that's it.